Today's topic that I would like to present here is about attacking backup softwares. Myself, Nibin Varghese. I work as a security researcher and a software developer in IT security. So about my organization, we are an on-demand penetration testing company. So this is regarding one such vulnerability that we found in backup softwares. And I will actually explain how I actually was able to get into the proof of concepts and exploitation part. So today's agenda would be about talking about backup softwares. I hope everyone understands what the purpose of backup softwares and the role of backup softwares in an enterprise. And also some history about the backup software vulnerabilities. Here I will actually also show one of the vulnerabilities that I found in two of the major vendors. And mostly it is about the demonstration of semantic backup exec software's NDMP man-in-the-middle attack. So this I consider as my FUD slide. So as a security researcher working in this industry, what I have understood is you have to create an FUD. So people understand what is FUD, right? Fear, uncertainty, and doubt. You have a backup software and security guys will come and say you should not use backup software. Or you will have a Windows operating system, researchers will come and say Windows operating system is full of bugs. So as a security researcher, I consider this as my FUD slide. Here, we all know backup softwares, the primary role of it is to protect your valuable data. Now data, confidential data in an organization, we need a backup software so that in case of, let's say, accidental corruptions of the data, we need to actually restore back to the original software or data. Now, my question is, from a security perspective, can we actually rely on these backup softwares? Because it is also a normal software which will have all kinds of attack vectors because it also opens up open ports. It also may have the wrong implementation of, let's say, protocols, which all can be different attack vectors for security vulnerabilities. Now, if you look at the two primary vendors who actually have these backup softwares, one is the Symantec and let's say HP Data Protector. So this was just a list of CVEs that I got from Secunia and CVE database, and you will see there are many more vulnerabilities that are actually disclosed in public. And out of here, the one that I will be presenting would be a CVE 2011-0546, which was identified by myself when I was working in Varghese. Now, why do you consider backup softwares are good targets? Let's say critical data are always backed up to prevent loss. Now, from a security perspective, what would be an attacker's motivation? So consider an attacker is there and he wants to actually, let's say it's in the enterprise network, an attacker is there and he wants to actually get some confidential information from there. So if I am looking for confidential information, do I have to exploit all the machines in the network? Or can I actually look for a software that is trusted by all the machines in the network? So I actually chose the latter approach for this particular topic. So you will see like the vulnerability in backup softwares are capable of providing, a sweet spot to an attacker to get into, let's say, getting confidential data. And here I will be explaining one such vulnerability, which is the CVE 2011-0546 semantic backup exec NTMP MIT attack. Now I will actually show you a short demonstration of this software, how it normally works. So this is the backup exec software. So in a normal operation, you will see like this would be the part which we call as the data management application. So this is the client part, and the other component is the data server provider, data service provider. So here, this is the part where it has an agent, and agent where it actually we set IP of the server where it needs to actually publish the data. And this is the part, so consider this as your laptop. So this virtual machine is your laptop from where I need to actually back up the data and it needs to be stored to the other machine. So in a normal operation, you will see like now there are two modes of actually taking backups. One is a person can actually manually go and set, let's say the backup administrator can go and manually set a backup, or it can be actually scheduled so that it can happen at regular point of regular levels. So here, this is my machine, which is a part where I have the agent installed. And if everything works fine, I can actually see the drives there. Consider I want to actually take the backup of this machine. And in the job monitor, you will see like, okay, it is taking the backup, and in some time it will actually be completed. So you have seen the normal operation of how this software works. Now I will go back to my presentation where I will explain where the attacks are. Now CD 2011-0546, otherwise called as the Semantic Backup Exec NTMP MITM attack. If you look at the timelines of disclosure, the bug was actually discovered in early 2009. That was in January 2009 I actually found the bug. And then later, as this particular bug was actually affecting NTMP, which is a primary protocol that is used for backup operations, so I actually kept it private within myself, so that I want to actually check this vulnerability with other implementations of NTMP. And I actually kept it for 1 year within myself. But the problem was many of the NTMP implementations was actually happening at the hardware level, and I was not actually able to access these hardwares where I need to actually test this vulnerability. So after 1 year keeping it within myself and checking 1 or 2 other software also, I finally decided, okay, there's no point in keeping it in myself, I will disclose it to the vendor. So in January 2010, I actually disclosed this bug to the vendor, and the vendor confirmed it in March 2010, somewhere after 2 months. And later we had a lot of communication within ourselves and themselves, and later they said they will actually fix it somewhere in the later half of 2011. So that means 1.5 years. The reason is because it was actually affecting an architectural flow in this software, which they cannot actually go and just fix it. They need to actually come up with a better solution to it. So finally Symantec released the patch in 26th of May 2011, and then we disclosed our advisory in 27th, and then later I published the proof of concept to ExploitDB in July. So you can actually get the proof of concept from ExploitDB, or you can actually get it from my GitHub account. Now, going to the place where primarily this talk is all about how I actually found the bug and what this bug is all about. So how many of you are actually assigned in finding vulnerabilities as part of your work? Is there anyone who is assigned? Okay, one guy, 2, 3. So I guess you will understand the sentiments behind it, how difficult it is to find a bug when you are actually assigned to find bugs. Like in your yearly, let's say, uprise, or maybe in your yearly performance, they will say like, okay, you have to find 5 vulnerabilities. They will have a number, and you know, like as a vulnerability researcher, it is so difficult to actually find. It is like finding a needle in a haystack. You don't know where it is, and if you happen to find, then you are lucky maybe. Or maybe if you, through hard work also, it might happen, but for my case it was quite frustrating to find a bug. And I will so here, if you look at the bug, it was just I was there at the right moment, and somehow some ideas came to me after discussing this with my superior at that time, who is Abhishek, who is sitting here. And that's the reason why I was able to find the bug and exploit it, basically. So I was looking for some softwares in, let's say, in late 2008 to first and find some vulnerabilities, and I got the semantic backup softwares. So any software with, let's say, any TCP communications port open is kind of very interesting for me. So I would like to actually first these protocols. So I started with survey of semantic backup exec softwares. So when I do the survey, we will actually go through the product sheets to see what are the features that it actually tries to implement. Then you will closely look at the technologies that it actually implements, and you will also look at the available network ports that is open there, so that you can actually try to see whether there will be any vulnerabilities. And then you start your fuzzing. You will start your fuzzers. I hope you understand what is a fuzzer. Yeah, so we will start our fuzzers to actually find this. So at first, you will try to look whether you are going to be very lucky. You will just blindly send some junk data to all the open ports and see whether the server is going to crash. So I tried that, and it was not a success. It failed. So I tried it running for, let's say, more than a week with random data, lots of data, GBs of data, and nothing worked. And later, you will actually try to capture the packets that is happening, the traffic between, you will capture the traffic that is happening between, let's say, the server and the client. And you will try to see whether there are any strings available there and try to mutate it, or maybe you will try to mutate like some of the integer values. And this mutation is what we call as fuzzing with the captured packets. So there is one tool which my colleague also wrote, Wireplay. So this is also a very good tool when we are going to use for, let's say, capture packets and fuzzing. And then later you will start, so that stage was also a failure. I captured the packets and tried to actually fuzz them, and that also didn't help me find anything. And third one was actually a protocol-based fuzzing. So here I used Surly. You know Surly? Yeah, have you heard of Surly? Okay, Surly is a fuzzing framework which is written in Python, and it can be used for block-based fuzzing. So here they had some minimal implementation of NTMP. I will talk about what is NTMP. So it is a protocol, it is like SMB. You understand what is SMB? Server message block? Yeah, so that is the protocol that is used, let's say, for Windows shares. You have some in 445 port, what is being opened and sharing is all about SMB, that the protocol is. So NTMP is similar to, even though it is not an SMB, but in the backup area, it is considered to be the protocol which is used for data sharing and transfers. So I tried with the protocol fuzzers like Sully, and that was also not possible to do. Now, I talked about NTMP. So NTMP is a network data management protocol, and it is based on a client-server model. So you will have a client will be logging to the server, and so then after that you will actually have post-authenticated commands that he can do and get the data if it's required. So this actually allows data storage, data transfers between various storage devices connected over a network. So NTMP in very generic terms. And NTMP has two channels. One is the data channel and the control channel. So mostly the commands, the logging, everything happens at the control channel. And later, if he needs to actually transfer data between the client and server, then they actually shift to the data channel. So actually in the challenges in fuzzing NTMP, you cannot actually directly go and use a protocol fuzzer there, because NTMP is actually driven by a state machine. So a state machine is like, there is a defined states, like you cannot actually, let's say like there is a state 1, state 2, state 3. If you want to write to stage 3, you need to actually pass stage 1 and stage 2. You cannot just directly go and first stage 3 and see some vulnerabilities in stage 3. Now, this is, so it is actually driven by the state machine. So even if you have, let's say, any freely available tools to do it, you need to actually, finally, if you need to get some of the results, you need to actually write some plugins of your own to manage the state and get into the crux of the problem to see the results. And also, NTMP, in NTMP terms, there are a lot of commands. And these commands needs to be actually gone in a sequence. Like first there's a, let's assume like I want to connect to a server. So he will actually send a connect open request. So for which I will get a reply. Then I will ask for a authentication request. I get a reply. Then I will ask for a authentication attribute request. Then he will send me a challenge. Then I will actually hash the challenge. So there is actually, you will see like there is a sequence of steps that needs to go. So you cannot actually bypass any states there. So when I was actually doing my survey, I found one academic paper which actually talks about the security analysis of the NTMP protocol. So this was a highly theoretical paper where they didn't had any proofs of exploitation, but looking it from an academic perspective and looking it from the security perspective of this protocol, they actually mentioned some of the probable attacks on this particular protocol. Like they call it in passive attacks and active attacks. So in passive attacks, as I mentioned, there is two channels actually. There is a data channel and a control channel. So in this data channel, if there is a person, let's say an attacker who is actually listening to the traffic, that data channel traffic, if he can capture it, then that is a serious vulnerability of information disclosure. Or consider in active attacks, what happens is NTMP, as it's using a sequence of commands, and if you have the control of, let's say, the client, if you have the control of the client, then you can actually ask the server to do some of the operations which he is not supposed to do, like deleting your directory or something like that, in NTMP terms. And also they have mentioned, like it is possible to do a man-in-the-middle attack on NTMP's MD5 authentication scheme. So here they didn't have any proofs. It is because when they closely analyzed this particular protocol for authentication, it was actually trusting anyone who is actually sending this MD5 challenges. He didn't actually verify like, okay, it is coming from a authorized source. So I will actually show how this, in a normal operation, an MD5 authentication will work like this. So there is a client, there is a server, and client will actually send a request to authenticate to the server, and server will send a 65 byte challenge back, for which the client has to send a hash, which he uses the challenge to actually create the hash out of it, and the hash will actually have the password also. I mean, the password is actually hashed. So at the server, he has the password, he knows the password and he knows the challenge, so he can actually recreate the hash and see whether those hashes matches. So based on that, server can actually authenticate the user, and then they can actually execute any post-authenticated commands. So this is how an NTMP MD5 based authentication works, if it supports MD5 authentication. Now, an MITM attack, a probable vector of attack, how it happens is something like this. Consider there is an attacker. Okay, this is at a very theoretical level. Practically, we haven't done anything. So at a theoretical level, they say, consider there is an attacker who is actually sitting right in the middle of the client and the server, and he is able to get the traffic from the client, and he can also listen to the traffic from the server. If that is the case, then client is actually requesting, let's say, to authenticate, and it is captured by the attacker, and the attacker is actually replying this to the server. And server is, as the server sees the traffic is coming from the attacker, he will actually be sending this back to the attacker, the challenge, and the challenge is actually replayed back to the client. Now, as the credential is there at the client, and as he sees like, okay, it is coming from, he doesn't know it is an attacker, he thinks that is a server. So now what he will do is he will use this challenge to create the hash, and he will send it back to the attacker. Now the attacker can actually send this reply back to the server, and the server will authenticate the client, and later these guys can actually, the attacker can do the post NTMP commands. He can execute the post NTMP commands. Now this is also at a very theoretical level. There is no proof. I mean, how we can actually exploit. After reading the paper, I understood, okay, this is a probable attack, but as they didn't, or in the internet or wherever I have done my survey, I haven't seen let's say, proof of concept of exploiting this. So practically, how can I validate this attack vector? So this I consider as a possible attack vector number one. So okay, I got the knowledge. Okay, there is a possible MITM attack there, but and the objective is to actually impersonate as a client to the server. So this is my objective. And I don't want to do any R poisoning in the LAN. So I hope you understand what is R poisoning. So I don't want to actually do an R poisoning where if there is a device in the network and it can actually detect R poisoning and all. So I want it to be as silent as possible, where if there is a client and if there is a server, and if I am an attacker, I want to do it as silent as possible so that none of them get alerted or none of the devices gets alerted. So I was actually looking for more clues. Okay, how can I do it? And for this particular software, there were two open ports. Okay, so 6101 was the port that was opened at the DMA. DMA was the, you have seen that semantics big UI, the big UI, which was actually where I scheduled the scan and all. So there was an open port at 6101, which is a TCP port, and there is a 10,000 TCP port, which is at the agent side, where let's say asking like that's your laptop, and at the laptop where you want to actually back up the data. So these are the two network ports that are open there. So far in DLE I explained. So there is a possibility of doing an MITM attack on that port. But what is that 6101 port doing there? So I was closely observing what that particular port was doing. And now that particular port, when I looked into the process that was actually responsible for opening that port, so that was a particular software called as the backup exec agent browser. Now the primary reason for this particular thing is that consider you have your laptop, okay, and you have these agents installed in your laptop. When you actually start your laptop, when it boots up, there is this particular agent who will actually broadcast one packet to this DMA application and say, hey, I am alive. So this actually informs that guy saying like, okay, he is alive and I can take backups at $11 if he is online. So this is one single packet which is like a broadcast packet that goes. Now that packet actually contains a NetBIOS name, it contains an IP address, and it actually establishes a connection, and it is a TCP packet, it is not even a UDP packet. I will actually show you the packet later in this step. And this packet is actually processed at the backup exec agent's browser. So this is the packet. So this is just one packet that is actually sent to that 6101 port, and it is a TCP port. And if you actually closely observe as a reverse engineer or whatever researcher, if you look at it, first you will look at the strings. You will see, okay, reverse engineering.backupserver.iosengine.com looks like something, and that is a NetBIOS name. And there is one particular thing which is that here, this actually, after reverse engineering the protocol, I found like this actually identifies the type of the host. Like RN was the type name for Windows servers, and if it was a Linux server, it actually varies, like RZ or something like that. And here this was an NetBIOS name, and what actually interested me was there was an IP address in that packet. So Z0 is 198, A8 is 192, 168.15. So the IP address was there. So now if you look at it, it is a TCP packet, and in the TCP packet you are setting an IP address also. Okay, so probably my doubt was coming like, okay, can I actually send some other address there and send it? I tried it, and the application was actually accepting it. It was not verifying like, okay, the source and the IP address are the same. It was not verifying this. So this was actually one way where I can actually spoof a valid client and be an attacker and get all his connections back. So through that, just by changing that IP address, I was able to actually publish fake IP addresses in the backup exec's main console. So it can actually see lots of fake IP addresses. And if I actually provide, let's say, the right NetBIOS name and an attacker's IP, then it gets registered as the NetBIOS name will be the same, but it will be connecting back to the attacker. So you will see, you will see like even though it was a TCP packet, if it was a UDP packet, there is no way of actually verifying the source, because UDP it is not reliable, and we cannot actually reliably say from where it came, because there is no connection back. So this attack vector was good enough for me to impersonate as a attacker, as a client, impersonate the attacker as a valid DSP. So here I will show you. So I have that attack vector 1, which is the MIPM attack on NTMP MD5, and second I have an attack vector 2, which is to actually spoof a valid DSP with an attacker IP. So I combined both of them, and I actually created an MITM attack on semantic backup exec to steal information. So that was actually, so right now I had two different attack vectors. I combined them and I was able to actually write a proof of concept now, which is going to be as clean as possible, and he is going to be as silent as possible. And I can actually still, let's say, get data from a client machine and without the knowledge of the server what is happening there. So this is just a sequence of diagrams that I have where I will show you what I have actually accomplished through the proof of concepts. So there are three primary actors in this sequence diagram if you see. So there is an attacker, there is a client, and there is a server. And here, at first, I told you there is a 6101 TCP port which is actually used to publish IP address, publish the details of the host who is actually coming online. So at first, as an attacker, I know who is the client and who is the server, and I will actually publish the information saying like, hey, I am the server. So I will actually publish this from the attacker side to the client application, to the DMA application. Now, later consider there is a scheduled backup operation that is going to happen. And what happens there is, after that, I will actually start a port, let's say a server port, which will actually look like a server application down there. So I will actually open an NTMP port there. And later, at the scheduled time, the client will actually connect back to my IP as I have already spoofed. He was trying to take a backup. And as in his registry, it was seen like it was the attacker's IP that was mapped to that domain name, that particular network's name. He will connect back to me. He won't connect to the original server. So he will connect back to me. He will request for authentication because he needs to take some backup. And as this is done, now as an attacker, what I will do is I will actually go and connect to the original server. Now to the original server, then I will actually ask him to authenticate. And he will actually, the server will actually send me a challenge. So this challenge I will actually reply back to the client. So now from the client, what happens is he will send me the credentials which is would be in the hash form. So he has the password. I don't have the password. I don't have anything. I'm just sitting right in the middle and just transferring packets from here to there and there to here. So here what happens is the challenge that came from the server, I sent it to the original client, and as he has the credentials, he will actually create the hash, and this hash will be, let's say, assume like it is a function of the challenge and the password, and the outcome is a hash. And this hash is, it comes back to me, and I will actually send it back to the server. And now, as the server sees it as a valid credential hash, so he will actually allow me to, he authenticates me. So after that, he will actually negotiate in operating. So these all are happening at the control channel level. And after there is an authentication happening at the control channel level, later they will actually negotiate. Let's say the attacker and the server can actually negotiate and come up to the data channel level, where they will be opening a different port, and then they can actually execute post NTMP authenticated commands. So this was my attack sequence, and that is what I have accomplished in my proof of concepts also. So if you look at it, the scope for the proof of concept was to actually explore the weakness in NTMP to execute post NTMP attacks, NTMP commands. If you look at NTMP, there are some messages. So you will see like it has messages, and there are some messages which should be executed at the client side. There are some messages that should be executed at the server side, and there will be proprietary messages also. So that protocol actually allows you to extend NTMP and have your own implementations of messages. Now, reversing their own implementation of protocols, proprietary protocols or messages was not part of the scope. because then it will go like, have you ever reverse engineered an RPC? Anyone? Okay, so if you reverse engineer RPC, you will see like the challenge is to actually identify what this message is actually. You don't know. There can be n number of. Have you actually developed an RPC stub or RPC server and client sending messages and all? Okay, so assume like, so there are these messages, and these messages from an attacker's perspective or a vulnerable researcher's perspective, I don't know what they are sending. I can only see some strings. I can make some basic assumptions like that will comprise of a type, a length, a value, but I still don't know what is that type. And you know, reverse engineering that proprietary protocols will take more time. And as the scope of this presentation, scope of this exercise was to find weakness in NTMP, I didn't actually go and reverse engineer the proprietary protocols. So right now, I will actually demonstrate the proof of concepts. So this proof of concept, if you look at it, I have actually, as I told you, the challenge in NTMP is to actually manage a state machine. So I started with one single file, then it actually grew up to, let's say, 5 different files of more than 1,000 lines of code, maybe more than 2,000, 3,000 lines of code. And this is just the entry point to that program. So here, you will see like, I actually accept some of the arguments where I need to know the DMA application, I need to know the DSP application. So see, like DSP is your laptop, DMA is the server where it will be backed up, and the third actor is myself, an attacker, and I also need to know the NetBIOS name of, let's say, the victim. So these are the arguments that I actually take from here. Can you see what I have written? It's too low. So you will see I have actually going to run the proof of concept, and I have given the different arguments as the client, the place where the DMA application is running, the minus S is for the place where I consider that to be a laptop from where I need to actually get the data, and I have given the NetBIOS name of the laptop or the DSP, and the fake server, the attacker's IP, and the domain name where these all are operating, backup server. And these are the references that I really helped me. Some of the references really helped me in actually reaching to this particular exploit. So you can see our advisory in our website, iwissecurity.com, and you can also see the semantics advisory of like the details, like okay, they have patched this particular vulnerability and crediting iwissecurity for finding this. Then the paper that actually influenced me in writing this exploit is the security analysis of the NDMP protocol. So that is an academic paper, which is a very good read. See, what I can tell you is this particular vulnerability, that NDMP's MD5 authentication scheme vulnerability, it is as per the protocol. They don't have a way to actually mitigate it. They don't have a, let's say, a PK infrastructure being discussed there so that you can actually mitigate this particular vulnerability. And if you want to get the proof of concepts, then you can actually get it from exploit.db, or you can actually follow me in GitHub and you will get it there. So, do you have any questions now?
Is there any possibility for code execution?
With this particular vector, attack vector, there is no possibility of code executions.
I mean, does NTFP has any option through which you can execute something on the remote system?
Well, see, these are messages. So if you see like NTMP, the kind of messages that gets executed at the server and the client is quite defined. So it is not actually accepting any user input which can be executed at the server side.
No, something like CMP.exe, something which is existing on the remote side. Command execution.
So far, I haven't found anything. But might be possible if somebody actually takes the research from this point and take it further.
NTMP is a open protocol, right?
Yeah, it is. It has a specification.
So when you're sending some data to the server for backup purposes, data can also be restored at some point of time.
Yeah, I can restore it.
So if you can restore a corrupt file because you are NTMP is an open protocol and you are right now in between NTMP and this.
Yes. See.
Then the possibility of code execution would be there or not?
Well, yes. In that case, there can be.
Like, can you restore some data on startup directory or somewhere?
You can restore. Yes, that you can do. See, there, if you have to reach to that point, what you have to do is, you have to actually reverse engineer some of the, see, Symantec has an implementation of this protocol, okay. NTMP defines, these are the open messages that anyway you must have, and it also allows you to extend this protocol to have your own proprietary implementations. So I have actually shown you, let's say, like, some of the messages in 04 series should be standard. They should actually operate as defined by the standards, and they actually allow you to extend, let's say, like after 80. So this actually identifies the messages. So after 8000, I guess it is for proprietary implementations, and at that point, if someone can actually reverse engineer what that message is particularly doing, yeah.
You were telling that this was an implementation of TAR.
It actually used the implementation of TAR.
If it is an implementation of TAR,
See, the point is, it was a TAR, and that I actually come to know after reading some documentation. I took the binary and tried to actually, let's say, untar it, but it was not like that. It was not. So from certain documentation, they say it is a TAR, because in Metasploit, there is one particular vulnerability in Symantec executable, where they had a backdoor in 2006 something. Okay, so in that backdoor, they actually tried to get all the data, and they actually get it in plain text also. So there they have mentioned like it was a TAR. So that is the reason why I actually said it could be a TAR. Now restoration is also possible, you know. So you do all the authentication and stuff like this, and later you restore what will be the data that is going to be in C file.
one more thing that we can that will be done. You deliberately try to update what to say virus or malware or something on your backup server, and then try to restore it, because you can do that. The propriety, the thing is the TAR archive, right?
Yeah.
And if you want to replace the TAR archive with something malicious, then that can be also done again. I can't get your point at how this vulnerability has been fixed.
See, this vulnerability has been fixed. Right now it was an MITM attack, right? So this vulnerability has been fixed by issuing certificates, So there's a PK infrastructure right now, and they actually set the credentials via in the SSL layer, and all the clients are also issued to have a certificate. So they make a certificate, let's say mutual authentication, and then on top of it only they are sending all these things.
MIT is impossible, but all these other that's
Might be. What you have mentioned, like restoring, let's say, with a malware, it is highly probable. I mean, if somebody is going to actually study that proprietary protocol and let's say define it, you step by step, you actually say, okay, this is what this particular message is doing. So if somebody has got the time and patience to actually go through it, maybe it is possible.